As we are seeing, the only oxygen is not going, only carbon dioxide is not going to return. At alveoli, generally what we can say when we explain like that. First we'll end oxygen transport, then we'll end carbon dioxide transport. But the thing, whatever happening in the body, it's not like that. That at a time at alveoli, oxygen going into the pulmonary capillaries, binding with oxygen to form the oxyhemoglobin, carbon dioxide, which is there in the three forms, as I said yesterday, that going into the particular alveoli is going to happen at a time. That means definitely oxygen and carbon dioxide influence one on each other. That influence of carbon dioxide on oxygen binding with hemoglobin and influence of oxygen on carbon dioxide binding with hemoglobin is going to be definitely seen over. That means here when you talk about HbO2, oxyhemoglobin, we discussed about the association and dissociation. Association means what you are looking, that is association. Means binding of oxygen with hemoglobin, what we said, binding of oxygen with hemoglobin, if you term it as association, if you term this as association, breakdown of oxyhemoglobin in the form of oxygen and hemoglobin is going to be dissociation, isn't it? This is association and this is dissociation. So definitely there is an association, dissociation. So if I ask you, I think you will answer this. Where does this association is going to happen? Location in the human body. We have two locations to see. One is alveoli and pulmonary capillaries, one of them. Alveoli and pulmonary capillaries. Okay, so the next heading will put at tissues. There we'll find tissues are there as well as systemic capillaries are there. Systemic capillaries. Okay, so we call these are systemic capillaries. So there are two locations where oxygen and carbon dioxide are moving. If you say here oxygen is moving to the tissues, carbon dioxide is moving from the tissues to the systemic capillaries. So I am asking here, where does oxygen bind with hemoglobin, bind with the oxygen and form oxyhemoglobin? Where this particular issue is going to happen? Yeah, oxygen binding with the hemoglobin will happen at alveoli between the pulmonary capillaries. Okay, then where does dissociation is happening? Means breakdown of hemoglobin, HbO2 breaking in the form of Hb, then O2. Where it is happening? At tissues. If you remember this, opposite is true for carbon dioxide, isn't it? So association at alveoli or pulmonary capillaries, dissociation at tissues, association at alveoli. Now, that for dissociation, let's talk about dissociation. What are the factors favorable for dissociation? Factors favorable for dissociation. Then if I ask about carbon dioxide, what about carbon dioxide? That should be high or low?
High, sir. High.
Very good. High. Then if I ask about temperature, high or low? Temperature should be high or low? High. High carbon dioxide, high temperature. pH should be low or high?
High.
Low pH. All these are for association, breaking down to break oxyhemoglobin into oxygen and hemoglobin. Low pH. H plus ion should be more or less. Yes, yes. Can't you get the screen?
I think, sir.
Okay, then. Edo antunaru?
Notifications వస్తున్నాయి.
Okay, okay. Yeah. Okay, then high carbon dioxide, low pH, high hydrogen ion, high temperature. You remember this, that for breakdown, okay, this is called Bohr effect. Influence of carbon dioxide and H plus ions. Influence of carbon dioxide and H plus ions on the breakdown of oxyhemoglobin. Influence of carbon dioxide and H plus ion for the breakdown of oxyhemoglobin we call Bohr effect, and the name of the scientist. Okay, so this is actually official. It is there in the textbook. Okay, what is Haldane effect? Haldane effect. Okay, just for formality here, Haldane effect is not there at all. But when you search for different kinds of books, you may find this. That's why I'm saying here. For the breakdown of carbamino hemoglobin, that so-called, we said about carbon dioxide also bind with the hemoglobin. Hemoglobin is going to bind with them. So in this particular reaction, will break down when high PO2 is present. So when you'll find high PO2, where you can see high PO2? Yeah, at alveoli, where oxygen partial pressure is high, that when pulmonary capillaries bring this kind of carbon dioxide, that definitely breaks HbCO2. High PO2, which is present here, definitely influence this particular phenomena. We call this particular phenomena as Haldane effect. And moreover, I already shown you to yesterday 4321. That means, let me 4321, before we go there, let me explain once that particular phenomena at tissues, carbon dioxide. Okay, let me say 1, 2, 3, 4. 1. What happened? Carbon dioxide dissolves in the water and form carbonic acid in the presence of carbonic anhydrase enzyme. Yeah, that is 1. 2. Carbonic acid divides into
formation of H plus and HCO.
Yeah, very good. That is 2. Okay. 3.
Cl from plasma.
Bicarbonate ions move into the plasma. In turn, chloride ions enters into the RBC. Very good. Then 4.
Reacts with HHB.
Yeah, H plus ions will break HbO2 that form HHB and release oxygen into the tissues. This is called Bohr effect. That's what we are talking about. This is Bohr effect. When more carbon dioxide is there, more carbonic acid. When more carbonic acid is there, more H plus ions are going to form. More H plus ions are there, more breakdown, and you get more oxygen. Isn't it or not? That's what we are talking about. That's what we are talking about. Okay, that is Bohr effect. This is itself called Bohr effect. It is Bohr effect. Okay. So in reverse, what we are saying, that when you go here, so when we by that when we see here at pulmonary capillaries, 4321, isn't it? Bicarbonate ions will back into the RBC. Then oxygen will come, breaks HHB and form HbO2, release the H plus ions, and H plus ions, HCO3 minus, again form H2CO3, that brings division H2O and CO2 will be released into the lungs. I am going little faster because we have completed this yesterday and making very small. Yeah. So that means you just imagine when oxygen is more, what happens? More it break down, more it form oxyhemoglobin, more H plus ions it release, more H plus ions form more carbonic acid. Oh my God. More carbonic acid will be released into the as carbon dioxide will be released into the alveoli. This is called Haldane effect, not there for us. Just you need to understand this relationship. As much as you practice, that much you understand these particular concepts and relationships. How many number of times I am going to say that no matter, you people need to practice this. Okay. Yes, please, someone that those are making noise, please mute yourself. Then let me once again. That means to explain chloride shift. When carbon dioxide dissolves in the water of RBC, one, that form carbonic acid. Okay, what is this? In the presence of an enzyme called carbonic anhydrase. Okay, this carbonic acid will divide into HCO3 minus and H plus ions. Yeah, HCO3 minus and H plus ions. Okay, so then let it be here. Let's talk about bicarbonate ions are moving into the plasma. Bicarbonate ions are moving into the plasma. Okay. Then in turn, what happened? Yeah, in turn, chloride ions are shifting to the RBC. What do you say this as?
Chloride shift.
That's it. Chloride shift. Okay, generally we call it as positive chloride shift. Positive chloride shift. And in the name of scientist, Hamburger, we call this feature as Hamburger's phenomena or Hamburger's shift. Hamburger's phenomena or Hamburger's shift. Okay, Hamburger's phenomena or Hamburger's shift. Okay, here in the three cases, you people need to remember one that this chloride shift, you people need to remember. And the first thing, whatever we said, Bohr effect. That you people need to remember this Bohr effect. Aldane effect, leave it. Bohr effect. These are very important for us. Okay. So then, let me end up the transport of gases, which we are discussing from a long period of time that we have to end up. I think the end up will be definitely cheerful because when I ask the questions, you people will answer immediately. So that make me cheerful, isn't it? Okay. Then oxygen partial pressure. Oxygen partial pressure in atmosphere. What is the oxygen partial pressure in atmosphere? I'll give time that oxygen partial pressure in alveoli. Yes,
104.
very good. But why answer not?
Atmospheric air is 159, sir.
159. Very good. We calculated it actually. Okay. Then oxygen.
104.
No, wait. Let me ask all. 104. Very good. Oxygen partial pressure in tissues at rest.
40.
Oxygen, very good. 40. Oxygen partial pressure in skeletal muscles at vigorous exercise.
22.
Hmm?
22 or 21.
Yeah, 20. Less than 40. Yeah, very good. Skeletal muscles at vigorous exercise. Need to answer for this. Vigorous exercise. That at skeletal muscles at vigorous exercise means definitely they use more oxygen, isn't it? So they use more oxygen. That's why they have less oxygen. Next, oxygen partial pressure in oxygenated blood.
95.
Yes, very good. 95 mm of Hg. 95 mm of Hg. Next, oxygen partial pressure in deoxygenated blood.
40, sir. 40, sir.
Very good. 40. That depends. We discussed about this. Generally, you can say 40. That depends. That's what we discussed about the pillow story.
Yes,
That depends. When you are at rest, when you are at likewise, that depends. Oxygen partial pressure, oxygen, my God, oxygen partial, spell mistake. Oxygen partial pressure in left atria, left ventricle. Actually, these kind of questions are very simple. You feel so because we practiced much. Left atria, left ventricle. I think answer should come here itself.
95, sir. 95.
Yeah, very good. Oxygenated blood. So we'll start from the beginning. Pulmonary vein, left atria, left ventricle. Then what should come? Left ventricle came. Then next. Yeah, left systemic aorta. Left systemic aorta. So in all these, oxygenated blood is present, isn't it? Next.
Yes, sir.
Next, the last one. Oxygen partial pressure in deoxygenated blood. So what should say? In vena cava, both vena cava, inferior and superior vena cava. Right atria. Right atria. Then after right ventricle. Right ventricle. Next. Yeah, pulmonary aorta. You see here how much scope is there for any examiner to ask the questions. Thousands of questions can be asked here. Sir, what to do? That to practice thousands of questions? No, just practice the concept, that's all. If we practice, I didn't say this before, we practiced it, we made it possible. Okay, so then let's start. I don't think so. I should write answers here. They need to be empty always. They need to be empty always. If any one of the particular answer, if it not, you're not getting after a month or a week, what we need to do, what you need to do? Yeah, very good. At least you didn't say it like that. That you just don't ask the answer. Don't ask the answer. You ask the concept. Sir, I forgot this concept. You please explain. Okay. So that's why never they are going to be filled over. Never these things are going to be filled over. If we have any problem, we need to revise the concept, not this one. Okay. Then next, in the same way, carbon dioxide is not going to be that much complicated with oxygen. That number of details are taken for oxygen. You don't take for much carbon dioxide. Okay, let's talk about carbon dioxide. Carbon dioxide partial pressure. So just let it complete in simpler way. Carbon dioxide partial pressure at atmosphere. Actually, we didn't discuss about this. 0.3. Because why? Enta. How much it is? 0.03% only. If you see, out of the gases, 21% is the oxygen, but carbon dioxide is very less in atmosphere. Okay, so that's why the first question, in atmosphere, that very less, that is 0.3 mm of Hg. That makes us to get easily, we can spread the carbon, release the carbon dioxide out. Okay, next, in alveoli, 40 mm of Hg is present. Yeah, I'm writing answers because we didn't discuss much about this during the classes, running classes. Okay, alveoli 40 mm of Hg. Then in that particular deoxygenated blood. Let's talk about deoxygenated blood. What is the meaning of deoxygenated blood? So that we have to, I don't think so we should write every time, but vena cava, right atria, right ventricle, pulmonary aorta, which these are the things people carrying deoxygenated blood with more carbon dioxide. How much more? How much more? That means 45 mm of H. 45 mm of H. So same way, oxygenated blood.
40 mm of it.
Then let it be oxygenated blood. What are the things carrying oxygenated? We start from pulmonary vein, left atria, left ventricle, left systemic aorta. All these are having oxygenated blood, isn't it? So how much it is? 40 mm of
40
H.
mm of
40 mm of H. Okay, so finally 1, 2, 3, 4. Last question here. Last question. At tissues.
45.
At tissues. Yeah, that they have more. They have more. 45 mm of each. So this is the complete partial pressure information, oxygen transport and carbon dioxide transport. Okay. So followed by these, that we can see that about the regulation of the respiratory movements also we need to discuss here.